So let's see in the next continuation lecture, gravitational field due to a circular arc. See here, I am taking a circular arc, right? The radius of this is the center of the arc. This is the center of the arc and this is radius. Or let it is having some mass m, right? This is a circular arc having some mass m. What is the mass of the arc? M. Okay. Let the arc, this angle we have taken as phi. What we have taken this angle? Phi. Part of a circle and this is the radius. Total mass is m, correct? Let's bisect it, equal half half. Right? That means this angle is going to be how much? Phi by 2. This angle is going to be how much? Pi by 2. Is that clear to all? Right? So what is the formula for gravitational field? G. At center we want to find, right? Gc is equal to how much? So G mass m by r square, but that will not happen. Because what we have to do, we have to take a small mass here, dm, right? Let's take a small mass here, dm. Getting now? Let's take a small mass here, dm, correct? And the total mass is distributed over the total angle phi. Mass is uniformly distributed. That means, let I told you this angle is 60 degree. This angle is 60 degree. This angle is how much? 60 degree. And the mass is let 60 kg. Mass is let 60 kg. Mass is let 60 kg. So in every 1 degree, how much mass you will be getting? So if I will be asking you what is the mass of this dm, so then you will be asking, sir, let this angle is, the dm is making, the dm, the small part dm is making an angle d theta. Getting my point? The total mass is m. We have considered small mass dm and let it is making an angle d theta, correct? And let this angle with the vertical is theta. With vertical this angle is theta. Understood all? What we are assuming the things? So to find the formula, to find the small gravitational field, what do we have to do? So G dm by, that's the thing we have to write, right? Because this is at a distance of r. The small mass is dm and that is the small gravitational field due to the small part of the arc, right? This is the formula. And to find dg, we have to integrate. We'll see how to find dg later on. But now the next step is to find dm. Next step is to find dm. Understanding all? If I'll be finding dm, then how to find dm? As I told, let total angle is 60 degree. Total angle is how much? Total mass is let 60 kg. Total mass is how much? If I'll be asking, let I'm taking 2 degree, how much mass will be there? 12 kg. In every 1 degree, 6 kg is there. So 2 degree means 2 kg. So like that, total mass by total angle, mass per unit angle into how much angle I am taking. So the small part that I have considered is dm, right? And the small angle I have taken is d theta. So I can write dm is equal to total mass m by total angle phi into d theta. Is that clear to all? Just say me. Let's see once again I'm saying, right? So this is the arc. Mass of the arc is m. Right. dgc is equal to gdm by r square. To find dm, total mass by total angle phi over the arc m by phi into d phi. Yes or no? Then this small angle dm, small part is dm. Let the, due to that the small gravitational field is dg. Let it is making an angle theta with the vertical. So it will be having one component dg cos theta and dg sin theta, right? If the same, from the same angle to the left side, if I'll be taking a small part dm, it will be also dg cos theta and it will be also having dg sin theta. So all the dg sin theta part will be cancelled out. And for the total arc, if I'm interested to find the total gravitational field, then I have to integrate all the dg cos theta, right? And you have already find dg is equal to how much? G dm by r square, and you have to replace dm, G dm by r square. And replace dm by m by phi d phi. Then G m r square phi is constant, I come out. Cos theta d theta integration is sin theta. And if from the vertical, if I'll be going left side, it is minus phi by 2, because exactly I have taken a bisector, right? Minus phi by 2 to limit plus phi by 2. I took the limit minus phi by 2 to plus phi by 2. Then cos theta integration is sin theta, then I removed. Then finally, for an arc, for any arc, if the angle will be given, if mass will be given and radius of the arc will be given, right? Then you can find the gravitational field at the center is nothing but 2gm by phi r square into sine phi by 2. Is that clear? The formula is clear to all? 1 minute. Just note it, students. All note it. Gc 2gm by phi r square sine phi by 2, right? Just remember that expression, and in back of the mind, just keep the derivations, because in 12 all the subjective exams this derivation might be required, and in some cases also this small concept will be used for. In 12th it will be all utilized concept, right? So next let's go to how to find the gravitational field due to a hollow sphere, a very small part, hollow sphere. About solid sphere, you just keep in mind how the acceleration due to gravity was varying for Earth, right? We have considered Earth to be a solid sphere. How the acceleration due to gravity at center it was 0. From 0 to the surface it was increasing, then from the surface it was decreasing. In the same way, the gravitational field is going to, because Gc is equal to gm by r square. That is gravitational field, and that is also gravitational acceleration due to gravity, right? So next, let's now see how the gravitational field is going to vary for a hollow sphere. For a hollow sphere. So let's see for hollow sphere, right? 2 minutes it will take to know hollow sphere. Students, this is a hollow sphere having radius r. This is the center. This is the surface, and this is outside. So 3 places where we are interested to find the gravitational field, right? Let mass is m. Mass is m. Let at a distance inside the point x. Let at a distance on the surface. Let at a distance outside the surface x. Outside the surface, on the surface, inside the surface, right? See here. The gravitational field of this will be we can get its influence. It is always radially inward. The gravitational field is always radially inward. Understanding now? The gravitational field due to a hollow sphere is radially inward. Correct? And if I am going a distance outside, g outside, at a distance x, that will be g m by x square. Understood? G surface, directly remember G surface, that is g m at what distance? At square. But one thing, G inside or G at the center, no mass is enclosed. And we have already found for a ring now the same concept, because every gravitational field will be cancelled out for the opposite part. It is a uniform hollow sphere. It's a uniform hollow sphere. So inside, for one thing you just remember, G inside is equal to 0. You know, because we have derived in ring, gravitational field for a ring inside, we have also found out ring 0, right? That concept you keep in mind. Another one thing you write, no mass is enclosed inside it, right? No mass is enclosed. No mass is enclosed inside the sphere. No mass is enclosed inside the sphere. No mass is enclosed inside the sphere. Understanding? Why I am saying no mass is enclosed? The same thing I will be repeating once in Gauss law of electrostatics. To find electric field, some flux will be required, some charge will be required. Charge is responsible for electric field. Mass is responsible for gravitational field. So total gravitational field depends how much mass is enclosed. Electric field depends how much charge is enclosed. No charge enclosed, no electric field. No mass enclosed, no gravitational field. Right? So here if I'll go for the graph, how it is varying, how the G is varying with distance x. Here x is equal to 0 means at the center 0. So up to r is equal to x, up to r is equal to x is equal to r, up to x is equal to r. Up to x is equal to r means from here if I'll go to the surface, no, on the surface the value will be maximum. That is how much? G m by r square. But after that, from this point it starts, the gravitational field strength starts from this point, from the surface, and outside as I go, it increases, it decreases, G proportional to x square. So this is the graph for this. And the concept for solid sphere, I'm saying, the concept for solid sphere is same as how acceleration due to gravity varies in case of acceleration due to gravity. I have derived that one in the same concept, only acceleration due to gravity will be replaced by gravitational field. We have also told last class that it is same only, correct? So due to a sphere, you got an idea? Outside will be there and the surface will be there, inside there will be not there. And this concept you can compare with ring. We have found with ring, right? Gravitational field that due to this part will be cancelled out by this part. Total will be cancelled. No field will be there inside the hollow sphere, correct? No mass is enclosed.